Hey everybody, what's going on? In this video, we're going to learn how to set up a high availability environment for HashiCorp Vault inside of Kubernetes. Now, first things first, I'm just going to go ahead and showcase what I got here. I am running a 3 worker node cluster in AWS EKS. I'm a few versions behind here. I should probably update my Terraform config, but this will still work nonetheless. So, first things first, what we're going to want to do is we essentially want to have two things here. We want the ability to auto unseal, because if we have high availability, that means that Vault is running on multiple pods. So we don't want to have to go in and auto unseal all of those pods. It would be a pain in the butt. So instead, we're going to have auto unseal turned on. Now to do that, I'm going to use AWS KMS. So I'm going to click create key, and I'm pretty much just literally going to leave all of this, default. I'm going to say EKS test, next. I'll put the key administrator as myself. Same thing, put the permissions as myself, and then I'm going to click finish. Okay. Now at this point, this is just an old one I have here, so don't worry about that. But at this point, I'm going to go ahead and I'm going to click on that key. And I'm going to copy the key ID, and I'm going to utilize that for later. Okay, so the next thing that I want to do is literally just going to open up a new text file here, pop this in so we don't forget that, okay? Now, the next thing that we want to do is we want to create a secret inside of Kubernetes. Why do we want to do that? Well, when we use KMS, we need Kubernetes to be able to authenticate to AWS. Even though it's running in EKS, it still needs a method of authenticating. Now, there are a few different methods that you can use here. There's one for the IRSA, the IAM role, instead of utilizing a Kubernetes secret. But in this case, we'll just keep it simple and we'll utilize a Kubernetes secret. So what I'm going to do is I'm going to generate a access key and a secret key. And the way that I'm going to do that is if I go to IAM, and I went ahead and just created all of that for the IAM stuff. That way you didn't have to watch me fumble around in the portal. All right. So I'm going to go ahead and I'm going to copy this. So I'm going to use the kubectl create secret command, and I'm going to call the secret EKS creds. Now, actually, before I do that, let me just create the Vault namespace because that's needed, as you can see. So we're going to go ahead and we're going to pop that secret in. All right, and now it is officially saved. So the next thing that we're going to want to do is we're going to want to add the Helm repo if you don't already have it for HashiCorp. And then you're going to want to run the Helm chart. But before we run the Helm chart, let's go ahead and break this thing down. Now this is pretty large, and typically if I'm running Helm commands, I'll use like the set flag and then I'll pass in values for the override. But this is a pretty big one, so we want to ensure that we actually have a file for this. All right, so we're ensuring that it's global. We're going to have the injector here for the Vault Kubernetes image. We're going to set some limits and some requests for the resources that are running for the pods. For the server, I want to ensure that there are PVCs available for the actual data, because the data, it's secrets, right? So it's not going to be ephemeral. We're going to need to save the data somewhere. Now, one thing to keep in mind here, we essentially, well, it depends. If you have a license for the enterprise image, you're going to want to utilize it here. If not, we're going to go ahead and we're going to use the community edition. Now, this is the community edition, so you're good here. So I should actually change this to use the enterprise or community image. All right, we're going to set up some resource requests and limits for that as well. We're going to set up our readiness probe and our liveness probe. We're going to enable audit storage. And here is where we're utilizing that secret that we just created. That way we can authenticate the AWS for the auto unseal. And then here is where the magic begins to happen for the high availability. So we're going to enable it. We're going to set 3 replicas. We have 3 worker nodes. So from a stateful set perspective, makes sense. We're going to enable Raft here. So it uses the Raft algorithm, which is the leader election. That's what Kubernetes actually uses as well to pick and choose what control plane is going to be the leader in the cluster. And then we have our Vault config here. Now, remember that AWS KMS ID? I'm going to go ahead and I'm going to copy that. And I'm going to paste it right here. All right, so this is the seal portion that's going to do the auto unseal for us. All right. We're going to set up the listener over port 8200. That's the Vault port that it listens on by default. And then the storage here, this is where the leader election comes into play. So we have 3 pods running, or 3 replicas. That's 3 instances of Vault. That means we want to have 3 retries here, right? It's going to be Vault 0, Vault 1, Vault 2. That's how it's configured. By default, when the stateful sets are set up, they're named automatically. So Vault 0, Vault 1, Vault 2, right? And then we're going to enable the UI here, okay? So again, a lot of configurations, but really what it comes down to is how your pods are going to look, how the high availability is going to look, and where the data is going to be stored. Because again, remember, Vault, it's storing secrets, so it's not ephemeral data. All right, so now let's go ahead and cd into Vault, Vault again, and we'll run this command right here, which is the Helm installation for Vault, and we're going to specify our override values.yaml. Okay, so that's deployed here. And then now what we want to do is we want to unseal that first pod, all right? And we notice here how we're just utilizing Vault 0. That's it. We don't have to worry about Vault 1 or Vault 2. We only have to worry about these for joining the cluster, okay? So the first thing is we want to run this command here. And what this command here is going to do is it's going to exec into the pod, and it's going to run the operator init, and then we're going to have the Vault unseal. Now, this may seem a bit cumbersome because we have to exec into pods, but this is the way Vault works. It's sealed by default. If it wasn't, there wouldn't be much of a point of using Vault. All right, so let's go ahead and run that. All right, and as you can see, it's unsealed. So what I'm going to do here is I'm going to copy this. I'm going to paste that in. And then we're going to run this Vault operator unseal command 3 times using 3 of these keys. All right, so let's go ahead and run that. So we'll do the first one, right? We'll do that again. We'll run the second one. All right, do that again. We'll run the third. Okay, so now what we can do is we can join Vault 1 and Vault 2. All right, so we're going to join it via the Vault operator wrap join command. Right, joined true. All right, and then let's join the second one. We do not need to do the operator unseal because, again, remember, we're doing the automatic unseal. Okay, cool. So now notice both of these are now joined, okay? So now if I run kubectl get all namespace vault, all right, we can now see Vault 1, 2, and 0 are running successfully. And if I go ahead and if I copy this, which is the load balancer for the Vault UI, and I open up a browser, let's do 8200, all right, Vault is now officially unsealed. And then if I go ahead and scroll up a little bit here, I'm going to copy that root token. Right, I am now officially signed in, and I'm signed in as root, of course, so we want to, change that at some point in production. But again, this is how you can get into Vault. So what did we do? A few different things. We installed Vault, we set up the override values, we unsealed it, and now we are officially good to go. Now, if we go ahead and we just, again, check this one more time, we can see that there are no restarts or anything like that on the pod. So what you'll see is if it's not set up properly, you'll see these pods continuously try to restart because they're trying to connect, but they can't. But we can see here that that's not happening, so we are good to go. And that's how you can configure Vault for high availability or HA in your EKS environment. Thank you so much for watching.